Hey Tube, welcome back. Today we continue our series in system design fundamentals. Today we will talk about the stateless architecture and why it's important to talk about the stateless architecture in big distributed systems. In the previous video we talked about the CDN, and after that we talked about the cache, and including to this. Let's just try to copy this system because we need it. Okay. Let me try to make it better for us. Yeah. Okay, so in the previous videos we talked about how to scale the data tier, and also we talk about the load balancer and what the importance of the load balancer will make the application available all the time and improve the performance and improve the latency. And we talk about the cache and why we need the cache to improve the latency and actually reduce the loads on the database by caching the frequently accessed data, so the data doesn't have to access it all the time. So now it's time to consider scaling the web tier horizontally. And what I mean about the web tier, I talk about the servers. Should I just take the servers and put them here, because most of our discussion will be about the servers. So for this we need to move, for instance, right now what we're doing, let's just describe what is the problem and how we can solve it. So let's say that we have user put a request. The request to go to the load balancer. The load balancer sends request to a specific server, and the server has its has like a user data session and have some specific information about the user. So and store in the cache or something like that, so it can just access it and just maybe return some information to the user. So let's just try to see how this work on high level. So let's assume that we have user 2, okay, and user 2 is connecting with server 2, okay, and we want to copy this one, and let's assume that we have more 2 users, and let's say that we have here user 3 and user 3 and user 1. I don't know, I'm not good at counting, but like just, so we have user 1 is connected to user 1, user 3 is connected with user 3, user 2 is connected with server 2. Okay, so in the stateful architecture, the server 1 here also stores the session data, for example, the session data for user 1, and it is the same with server 3. It stores the session data of user let me just for user 3, and the same here also, it stores the session data for user 2, and maybe they have like profile image, stuff like that about the user. So, and this looks good, it works fine. However, when we have one of the servers just went down, let's say that this server 1 went down, the load balancer will try to redirect user 1 maybe to server 3, okay, and server 3 doesn't have the information of user number 1, so the data right now of user number 1 is lost. So basically we can find user number 1 when user number 1 try to communicate or to try to obtain its data from server 3, it can't. So from this way, the issue here is that every request from the same client must be routed to the same server, that we can do this by sticky session or something like that in most load balancers. However, this adds this will add like a more level of difficulties, you know, and this will add and this add the overhead. Adding or moving servers is much more difficult with this approach. So how can we solve this problem? Is to go to something called a stateless. So basically our servers doesn't have any state. They doesn't have any state. So we read all of that state from all of our servers, and instead of saving the state, so in the servers we use a shared database. Okay, and in this shared database, maybe it could be NoSQL or something. It's just shared storage that all servers taken from its data. So basically here what will get what is going to happen to when let's just call it this to be db. So basically I'm not good at the b. Let's just try to do the b again. Okay, this is not bad. This is not bad. Okay, so basically when user number one is it's connecting with server number one, when for some instance connect instead with server number three, user number one still gets its data because all of the servers using the shared database to get the user information. So basically right now the web tier doesn't store any state. So from this we can delete as many servers as we want. We could add new servers if we want. Okay, we could route the requests of the users to different servers if you want, and we expect to have the same functionality all the time. So right now our application will be way more reliable, way more sustainable, and will improve the user experience after all. So how we can achieve that? Let's just go upstairs, and I guess I need to delete all of that because there's no need to have all of that. Let's just let's say that we have here. Oh, oh, this is big. No, no, thank you. So let's copy the cache and have here. I will call it where should I put it actually? Let's just take the cache downside down a little bit down, yeah, and let's just take these a little bit down like that, and take the cache also down. Oh no, the cache down. Yeah, I didn't mean down like that, but like okay. Okay, that's not bad after all. Okay. So right now we have this one, which will be a shared database. Maybe we use NoSQL, and I will say why we're using NoSQL, because everything has a reason in system design interview. Everything has a reason. Like, do not take any decision in system design interview without saying its reason. This is one of the biggest red flags in system design interview. So let's just make it red, and just okay, this one. Let's just add a new one here, and just can we just make posts like go from here? So basically, in this stateless architecture that you can see here, the HTTP request from users can be sent to any web servers, which fetch state data from the shared data store here, and the state data is stored in a shared data store and kept out of the web servers. A stateless system is simple and more robust and scalable. So basically what's going to happen here, we move the session data out of the web tier and store them in a persistent persistent data store. The shared data store could be a relational database or memcache Redis database or NoSQL. We choose the NoSQL data store is chosen here as it is easy to scale. So like we have auto scaling, and auto scaling basically means adding or removing web servers automatically based on the traffic load. Is something easy to do. After the state data is removed out of the web servers, auto scaling of the web tier is easily achieved by adding or removing the servers on the traffic load. So we can add servers, remove servers, no problem, because all of them they are accessing the user state from the from a shared store. So it doesn't matter into which user or to which server the user is connected to, so because of that. So yeah, that's it for today's video about the stateless architecture. I hope you like my description. If you like my description, I hope if you like my description, make sure to subscribe and hit the notification bell so you will never miss a video, and see you in future problems.